Welcome to DjamgaMind, your ads-free audio intelligence platform. I'm Etienne Noumen. It is Thursday, March 12th, 2026. Today we focus on the sovereign infrastructure shift. Perplexity has launched a dedicated Mac Mini agent. Elon Musk has merged xAI and Tesla into a single agentic project called Macrohard. And Nvidia has committed $26 billion to save the Western open source ecosystem. No fluff, no ads. Let's dive into the data.
On March 12th, an autonomous system pushed a piece of code that, well, it looked perfectly fine in isolation, you know.
Right. I mean, on paper, it was flawless.
Exactly. It passed the static assertions, the automated testing suite gave it a green light. Everything looked good.
Until it hit production.
Right. 24 hours later, 6.3 million real-world orders they completely vanished from the logistics pipeline.
Oof, gone.
Just gone. And $6 million in revenue evaporated with them. And this didn't happen to, like, some poorly funded startup running beta software, right? It happened to Amazon.
Which is just, it's wild to even think about.
It really is. So welcome to today's DjamgaMind briefing. If you're listening to this deep dive, consider yourself sitting in a locked-door strategy room with us, two elite systems architects just dissecting the bleeding edge of the industry.
Yeah, and we've got a massive data dump from March 12, 2026 to get through today.
We really do. So our objective today is to map out this brutal industry-wide architectural collision. We are unpacking vertical integration in the agentic era.
And, the stakes underlying that Amazon pillar you just mentioned, that is exactly why we need to examine the physical infrastructure layer today.
Yeah, the actual hardware.
Right, because for the last 20 years, I mean, the ultimate goal in enterprise architecture was just abstraction.
Yeah, push it all to the cloud.
Exactly. You took the servers, the hard drives, those messy tangles of physical wires, and you just shoved them into the cloud. The physical layer was basically someone else's problem.
You just focus on the application logic. But the data we're analyzing today, it signals this violent reversal of that trend.
A total 180. Gravity is like returning to the system.
I like that. Gravity is returning.
Yeah, because the abstract stateless cloud, it's no longer sufficient for the workflows we're demanding now.
No, not at all. We're literally dragging the core logic of these systems back down to earth, anchoring them to local hardware, and hardwiring them into custom silicon.
Which is a huge shift for anyone building these systems right now.
It really is. And we're going to examine the shift from 4 distinct angles today. First, we're tearing down Perplexity's highly unexpected hardware pivot.
Yeah, deploying agents on local machines.
Yeah.
Crazy.
Then we're going to look at Elon Musk's Macrohard architecture, which is attempting to, emulate entire corporate structures.
Right, by feeding operating systems through autonomous vehicle vision pipelines.
Which is just a wild concept. From there, we map Nvidia's $26 billion open source gambit.
And the really specific hybrid architectures making that even possible.
Yeah. And finally, we bring it all back to that brutal operational reset at Amazon, which serves as, the ultimate reality check for everything we're building.
Because if it breaks Amazon, it's going to break everyone else.
Exactly. And just a quick note for you listening, this briefing is purely data-driven, it's extremely high density, and focused entirely on how these shifting paradigms impact the systems you are architecting right now.
So let's start at the physical endpoint.
Yeah, let's do it. So Perplexity just debuted what they are calling, quite simply, personal computer.
Which is, frankly, a brilliant piece of deceptive naming.
Oh, absolutely.
Because it fundamentally redefines what the computer actually does. I mean, they've introduced a dedicated, localized version of their computer AI agent system.
Right.
But rather than running it through, a distributed cloud environment, it runs 247 on a physical Mac Mini.
A literal box on a desk.
A physical box. And they're explicitly positioning this as a highly controlled, secure enterprise rival to the OpenClaw agent that went viral earlier this year.
Okay, let's unpack this. Because the specs they released, they show this isn't just a localized chatbot. The Comet Assistant has persistent local access to files, applications, and user sessions on that specific physical device.
Yeah, it's fully integrated into the local environment.
And the enterprise tier they're pushing, it taps into 20 different models simultaneously. It orchestrates over 400 distinct app connections.
And it integrates directly into Slack for team workflows, too.
Right. And Mac subscribers are getting early access via a wait list right now. I mean, it's like we spent the last 20 years moving everything from the desktop to the cloud to escape hardware limitations.
Right. The whole thin client dream.
Exactly. And now Perplexity is essentially parachuting an autonomous brain back onto the physical desk. So the immediate architectural question is why? Why are we regressing to dedicated local hardware to run advanced AI?
Well, the regression is actually an evolution. It's driven by the limitations of statefulness and latency in cloud architecture.
Okay, walk us through that.
Sure. If we examine the friction developers have experienced with purely cloud-based agents over the past year, the structural bottlenecks are they're glaringly obvious.
Oh, for sure. Latency being the big one.
Right. First, consider the round-trip latency. Sending a complex, multi-step reasoning task to a cloud server, like, say, parsing an Excel sheet, cross-referencing it with an internal CRM, and drafting an email.
That requires data serialization and network transit.
Exactly. And when an agent is trying to interact with a local application interface in real time, that network latency makes the execution feel agonizingly slow.
And brittle. Like you end up with synchronization errors constantly.
Oh, constantly.
The cloud agent thinks it clicked a button, but the local UI hasn't fully rendered the new state yet.
Right, so the agent's next move just completely breaks the workflow. It clicks on empty space or the wrong menu.
Exactly. It falls out of sync with the environment it's trying to manipulate.
And the second bottleneck is context decay. Cloud sessions are ephemeral by design.
Right, they time out to preserve server resources.
Exactly. So when a session drops, a cloud agent loses the intricate, multi-layered state of the machine. It forgets what windows were layered on top of each other.
Or what the user's cursor was hovering over.
Right, or what the exact local file paths were.
Yeah.
But by anchoring the Comet agent to a local machine, specifically a Mac Mini, you bypass the network entirely.
The agent just lives on the same motherboard as the work.
Exactly. It has direct, persistent access to the local memory stack.
And that actually brings up a really critical hardware optimization point. Apple's M-series silicon utilizes a unified memory architecture.
Which is huge for AI inference.
Massive. The CPU, the GPU, and the neural engine all share the exact same pool of memory. So when the Comet agent is analyzing like a massive local data set,
It doesn't have to copy that data back and forth.
right, it doesn't shuttle it between system RAM and a separate graphics card, which is what happens in a traditional PC architecture.
Yeah.
It just reads the local state instantaneously.
Yeah, which makes the Mac Mini uniquely suited for running these heavy, persistent background models.
Without, thermal throttling or melting down the user's primary workstation.
Exactly. That unified memory architecture is precisely why Apple is, almost unintentionally, becoming the default hardware backbone for this localized AI agent era.
The silicon is just perfectly optimized for it.
It really is. It allows for the continuous high-bandwidth memory access that a persistent agent needs. But, Perplexity's strategy goes far beyond just memory efficiency.
Oh, where else are they taking this?
Well, what's fascinating here is how they are framing this deployment entirely around the concept of physical security.
Oh, right, the safety boundaries.
Yeah, verifiable safety boundaries.
Right.
They're utilizing the physical constraints of the hardware to mitigate the existential risks of deploying autonomous systems in enterprise environments.
And the source data emphasizes that heavily. Perplexity is advertising tracked activity logs, explicit cryptographic sign-offs for sensitive system tasks.
And that physical kill switch they keep mentioning.
Yeah, the kill switch, to immediately sever the system if the agent hallucinates like a disastrous command string.
Which is brilliant, because you cannot put a physical kill switch on a distributed AWS Lambda function.
No, absolutely not. If a cloud-based agent goes rogue and starts recursively deleting S3 buckets, it's operating at the speed of the data center's internal network.
Right. By the time the telemetry even alerts a human engineer, the damage is already irreversible.
But you can physically, or at the network hardware level, just pull the plug on a Mac Mini.
Exactly.
Let me push back on the practicality of that for a second, though.
Sure.
If I am the enterprise systems architect for a global financial firm, and I'm tasked with deploying 1,000 of these Comet agents to automate our quantitative analysis and HR workflows,
Right.
the logistics sound absurd. Am I genuinely supposed to procure 1,000 physical Mac Minis? Am I racking them in a literal closet in our London office?
It does sound a bit archaic.
And how does a physical kill switch function dynamically across a remote workforce? If an agent deployed in our Tokyo branch starts hallucinating and wiping production databases, is a local office manager supposed to, like, sprint across the room and yank the power cord?
I mean, that friction highlights the awkward transitional phase of the current infrastructure we're in.
Yeah.
For early enterprise adopters running highly sensitive data-think defense contractors or healthcare providers, they might literally be stacking these Mac Minis in secure Faraday-caged server closets.
Wow. So physical isolation really is the feature, not a bug.
Absolutely.
Hmm.
But for the global financial firm in your example, the kill switch is virtualized at the switch layer.
Ah, okay. Treating the hardware as a quarantined node.
Exactly. You implement a zero-trust network architecture, but apply it to the internal hardware itself.
I see. So if a traditional cloud agent gets compromised, it's already authenticated inside your corporate perimeter. It operates laterally across your cloud infrastructure.
Right. But if a localized Mac Mini agent hallucinates, it's physically constrained.
Oh.
You just sever that specific machine's MAC address from the corporate internet via your network management tools.
The hardware creates a literal containment cell.
Precisely. The AI can think and act with near zero latency locally, but the blast radius of a failure is constrained to that specific box.
It's treating the hardware as a blast shield.
Yes, a blast shield.
That makes structural sense when you consider how chaotic unconstrained agents can be. But Perplexity is building these localized, contained nodes for specific bounded desktop workflows. They're putting walls around the intelligence.
It's very strict walls.
But our next data point shows a competitor taking the exact opposite approach. They are trying to vertically integrate the entire concept of a software company into one unconstrained, monolithic stack.
Ah, yes. Elon Musk's Macrohard revival.
Yeah. The ambition here represents a completely different philosophy of systems architecture. Let's analyze the data dump on this.
A massive pivot.
It is. Musk just publicly refuted reports that his AI software initiative, Macrohard, had stalled. Instead, he revealed that xAI's project is officially merging with Tesla's digital Optimus's AI agent.
And the stated objective is just staggering.
It really is. They intend to create a system that can, quote, emulate the function of entire companies.
To understand the audacity of that claim, we really need to break down the architectural stack they're assembling here.
Let's do it. What's under the hood?
They are taking the Grok large language model, which serves as the core reasoning engine and semantic logic layer.
Okay.
They are pairing that with the new digital Optimus's execution agent, and they are running the entire system on a completely proprietary hardware pipeline.
Right. Musk states it will run on Tesla's $650 AI-4 chip, functioning as the localized inference node.
Which then communicates with xAI's massive Nvidia-based server clusters for the heavy compute.
He's marketing this as the only real-time smart AI system available today, but the crucial technical detail from the sources is how this system interacts with software.
This is the craziest part.
It really is. It processes live, real-time computer screen video combined with keyboard and mouse inputs by borrowing techniques directly from Tesla's FSD, the full self-driving vision technology.
Yep.
Here's where it gets really interesting, folks. They aren't writing specialized API connectors. They aren't parsing the underlying code of a website.
No HTML reading at all.
Exactly. They are literally strapping a self-driving car's visual cortex in front of a computer monitor and telling it to drive the software visually.
It's wild. And if we connect this to the bigger picture, this is arguably the most aggressively vertically integrated play in the history of the industry.
Oh, without a doubt.
Think about the dependencies required to build a truly autonomous multimodal agent. You need custom silicon optimized for real-time sensor fusion.
Which Musk controls with the AI-4 chip.
Right. You need a massive repository of spatial and visual training data to teach a model how to interpret complex moving environments.
And Musk has the largest data set on Earth for millions of Tesla vehicles navigating physical roads.
Exactly. Then you need a frontier-class reasoning engine to determine intent.
That's Grok.
That is Grok. And finally, you need the massive liquid-cooled server infrastructure to train the overarching weights.
Which is xAI.
Precisely.
So he owns the entire supply chain of cognition. From the sand used to fab the custom silicon all the way up through the logic layer making the strategic corporate decisions.
The control of the stack is absolute. But the translation of the FSD vision system into the digital realm, that's the primary engineering breakthrough here.
How so? Contrast it with what we're doing now.
Well, historically, if an AI agent needs to interact with a SaaS application, it does so structurally.
Right. It reads the document object model, the DOM of the web page.
Yes, it looks for specific HTML tags, or it interacts with clean JSON payloads via an API endpoint. It relies on the software being logically documented.
Which introduces massive fragility.
Huge fragility.
If the developers of that SaaS application deploy an update that changes the name of a CSS class, or if they deprecate an API endpoint without warning,
The structural agent instantly breaks.
it throws an error because the underlying skeleton of the application shifted.
Right, and that fragility makes company-wide emulation impossible. You cannot automate a legacy enterprise if your agents break every time a web interface updates.
It's just too brittle.
Exactly.
Hmm.
Macrohard's approach circumvents this entirely by treating the operating system as a physical environment.
It just looks at the screen.
It doesn't care about the underlying code. It uses vector space mapping applied to a 2D digital interface. It looks at the pixels on the screen the same way the FSD neural net looks at a pedestrian crossing a street or a traffic light turning yellow.
Wow. So if a submit button on an internal logistics dashboard is randomly moved 3 pixels to the left during a UI update,
A traditional agent crashes because the coordinate map or the DOM selector is invalid.
but the digital Optimus agent just visually identifies the semantic concept of the submit button, adjusts its trajectory, and clicks it.
Exactly. It's interacting with the visual output layer, not the architectural hidden layer.
That spatial processing allows the agent to interact with literally any software ever written.
Anything.
It doesn't matter if it's a heavily documented modern web app or a completely undocumented, bespoke AS400 terminal emulator from 1998 running in a virtual machine.
If the interface can be rendered as pixels on a screen, the FSD vision pipeline can interpret it.
And the Grok reasoning engine can learn how to manipulate it.
Yes. That is the mechanical pathway to emulating the function of an entire company. You drop this agent into a chaotic digital environment, and it figures out how to run payroll visually.
It's a beautifully elegant theoretical model. But as an architect, I have to look at the friction we're seeing in the source material because the operational reality on the ground appears significantly more chaotic than the pitch deck.
Oh, the talent bleed is a massive red flag.
Huge. Business Insider reported that over 20 Macrohard engineers have recently departed or shifted roles. A massive 600-person data project critical to the system has been completely paused.
Yeah, that's not a minor hiccup.
Furthermore, while xAI merged with SpaceX for operational efficiency in February, they've suffered a severe wave of top-tier employee exits over the last month, including several of the original co-founders.
And a talent bleed of that magnitude at the foundation model level is incredibly disruptive.
It brings the viability of the entire monolithic structure into question. I mean, you can design the most vertically integrated stack on the planet, but if the specific engineers who understand how the local AI4 silicon interfaces with the visual neural network of Grok walk out the door,
The whole system becomes a liability.
right. The institutional knowledge required to maintain a custom closed ecosystem is immense.
That is the ultimate vulnerability of vertical integration.
Yeah.
When you build a proprietary walled garden where every single component, the chip, the vision pipeline, the reasoning engine.
Where everything is custom machined to interlock exclusively.
Exactly. You create a system with infinite complexity and zero modularity. If you lose the lead architect of the AI4 integration layer, you cannot just hire a senior developer who knows standard open source frameworks. The learning curve to understand the bespoke internal architecture is practically vertical.
The system is just too tightly coupled.
Exactly the problem. And this operational friction highlights a massive structural divide forming in the industry right now.
How so?
Well, Musk is attempting to build a completely closed, custom silicon ecosystem. But the broader developer community, the millions of systems architects listening to this deep dive who do not work inside the xAI walled garden.
They can't build their enterprise solutions on a closed proprietary pipeline.
Exactly. They require foundational open source infrastructure to build their own multi-agent workflows.
And historically, the Western development ecosystem relied heavily on Meta's open-weight llama models to provide that foundational layer.
Right, Meta was the cornerstone.
But as the data shows Meta pulling back from the bleeding edge of open source deployment, a critical vacuum has opened in the market.
A vacuum that completely shifted the balance of power in foundational models. Which brings us to the third massive pivot in our data dump.
Yes. Nvidia is stepping in to seize control of that open source infrastructure layer.
And they're bringing a massive war chest to command.
$26 billion. They are committing $26 billion over the next 5 years specifically to build and release open-weight AI models.
Now, we need to be very precise about the global context here.
Absolutely. And just to interject a strict impartiality note for our listeners, when we discuss Western versus Chinese models here, we are purely analyzing the global market dynamics and supply chain strategies as reported in the sources.
Right. We are taking absolutely no political stance here.
Exactly. We're just looking at the data. And the sources explicitly note that Nvidia's move is designed to fill the gap left by Meta, and critically, to provide a competitive Western alternative to Chinese models like DeepSeek and Qwen.
Because the data indicates these Chinese models currently dominate the open source performance benchmarks.
Right, and they are reportedly being trained heavily on domestic Huawei silicon. So we need to analyze this purely through the lens of supply chain strategy and benchmark data.
Right. Nvidia is a publicly traded corporation reacting to a shift in the developer ecosystem where the most performant, accessible models were originating outside their hardware sphere of influence.
It is a textbook ecosystem defense mechanism.
Exactly. Developers are aggressively pragmatic. They will gravitate toward the model that provides the highest benchmark performance for the lowest inference cost, regardless of its origin.
Yeah, if DeepSeek is shipping a mixture of experts model that beats Western equivalents on coding benchmarks, the global developer base will integrate DeepSeek into their CI/CD pipelines.
And NVIDIA's executive team recognized that if the software layer of the AI revolution standardizes on architectures optimized for non-NVIDIA hardware,
their long-term moat evaporates.
Yes. So the $26 billion commitment is literally the cost of defending the software ecosystem to protect the hardware monopoly.
Okay, let's examine the specific architecture of the weapon NVIDIA just deployed into this ecosystem. Nemotron 3 Super.
The specs on this are incredible.
The technical specifications are staggering. The data details a 128 billion parameter model, with some technical documentation referring to it as 120 billion.
Right, massive scale.
It is achieving inference speeds 5 times faster than previous generations. On raw reasoning tasks, it is matching the performance of Anthropic's Claude 4.5 Haiku.
Though the benchmarks note it still trails slightly behind frontier competitors like Qwen 3.5 in certain domains.
True. But the critical engineering detail, the piece that fundamentally alters how we build systems, is the architecture itself. The Nemotron 3 Super is a hybrid Transformer-Mamba model.
And that is the game changer.
Built explicitly with a 1 million token context window to support multi-agent workflows.
We really must dissect that hybrid architecture because Transformer-Mamba hybrid is not just a marketing term.
No, it's highly functional.
It is the solution to the most severe mathematical bottleneck in machine learning today.
Explain that for us.
Okay, so for the past several years, the entire generative AI industry has been constructed on top of the transformer architecture.
Right.
Transformers are unparalleled at dense, complex reasoning and understanding the intricate relationships between distinct concepts in a data set. But their core mechanism, this self-attention matrix, has a fatal mathematical flaw.
The computational complexity scales quadratically, O of n squared.
Precisely. Let's visualize the mechanics of that quadratic scaling. In a standard transformer, the attention mechanism forces every single token, every word or fragment of code, to calculate its relationship to every other token in the sequence.
Okay.
If you feed the model 10 tokens, it calculates 100 relationships. If you feed it 1,000 tokens, it calculates 1,000,000 relationships.
So if you attempt to feed it 1,000,000 tokens...
the matrix explodes to 1,000,000,000,000 relationships for a single inference pass.
Wow.
The memory bandwidth required to store and compute that attention matrix fundamentally breaks the GPU architecture.
The system literally runs out of VRAM and hard crashes.
Exactly. This is why, historically, if you pasted a massive code base into an LLM, it would truncate the input or simply refuse the prompt. The math physically prevented it from holding that much context.
And that hard limit was the primary roadblock to true agentic automation.
Right.
Because if you're building a multi-agent workflow where you have a senior architect agent, a junior coding agent, and a QA testing agent collaborating.
They need to see everything.
Exactly. They need to be able to read an entire corporate code base, analyze 10 years of Jira tickets, and cross-reference API documentation simultaneously. A 1 million token context window allows you to load roughly 3,000 pages of raw dense code into the active short-term memory of the model at once.
But as we just established, you cannot do that with a pure transformer without melting the data center.
Right, so enter the Mamba architecture.
Mamba represents a completely different approach to sequence modeling, known as a state-space model. Its fundamental superpower is that it scales linearly, not quadratically.
Linearly. Okay, how does that work under the hood?
Instead of forcing every token to look at every historical token simultaneously, Mamba utilizes continuous time equations to compress the past into a highly optimized rolling hidden state.
Okay, so it's a functional difference in memory management.
Exactly.
Let me try an analogy here. If a transformer is a student who spreads 3,000 pages of a textbook across a massive desk and tries to read every page at the exact same time to find connections.
Right.
Mama is a student who reads the book sequentially from start to finish, taking incredibly dense, compressed shorthand notes as they go.
I love that.
They only need enough desk space for their current notebook.
That is an excellent mechanical analogy. The state-space model only requires a constant amount of memory, regardless of how long the sequence gets. It sweeps up those 1 million tokens of context linearly and efficiently, without the exponential memory penalty.
Okay, but there's a catch, right?
There is. Pure Mamba models historically struggle with the deep nonlinear reasoning required for complex coding tasks. They are phenomenal at retrieving data, but less capable of abstracting new logic from it.
So NVIDIA's engineering team mashed the two architectures together.
They engineered a hybrid routing system. They utilized the Mamba architecture blocks to handle the sheer volume of the data intake.
Compressing and filtering the million token sequence to identify the relevant signals?
Yes. Then they route those compressed, high-value signals into the transformer architecture blocks to apply the dense, complex reasoning. It is an incredibly elegant solution.
So the Mamba layer acts as a massive high-speed radar system sweeping the entire environment.
And the transformer layer acts as the precision sniper scope, focusing on the exact target.
Okay, so from a technical perspective, the hybrid architecture is a masterpiece. It solves the context bottleneck. But looking at the business logic, I have to question the underlying strategy here.
The $26 billion question.
Exactly. Nvidia is a hardware manufacturer. Their entire market capitalization is based on selling physical silicon. What is the financial justification for pouring $26 billion into developing this bleeding-edge software, only to release the weights for free under an open-source license?
The justification is absolute ecosystem lock-in.
Lock-in.
It is arguably the most aggressive, well-funded loss leader strategy in the history of enterprise technology. Nvidia released the model weights freely, but if you scrutinize the technical documentation accompanying the March 12th release, a crucial detail emerges.
Oh.
These hybrid models are optimized at the CEDA level, strictly for Nvidia hardware architectures.
Ah. So they open-sourced the logic, but they proprietary locked the execution environment.
Exactly. Nvidia does not want to sell you a software subscription. They want to ensure that when you, as an enterprise architect, prototype a massive multi-agent workflow using Nemotron 3 Super.
You realize that to achieve those 5x faster inference speeds, you need their chips.
Right, and to utilize the Mamba linear scaling efficiently without constant memory swapping, you must run it on the latest generation of Nvidia GPUs.
They are heavily subsidizing the open source software layer to guarantee an inescapable monopoly on the hardware procurement layer.
If you integrate Nemotron into the core of your corporate infrastructure, you are effectively mandating that your future data center budget flows directly to Nvidia.
It's a brilliant strategic maneuver. It counters the benchmark dominance of DeepSeek. It establishes a foundational standard for the Western developer ecosystem, and it guarantees that the massive compute requirements of million token context windows translates directly into GPU sales.
It's a masterclass in ecosystem defense.
Let's synthesize the briefing up to this point, because the convergence of these technologies is critical.
Yeah, let's tie it all together.
We have Perplexity demonstrating that persistent agents require localized hardware nodes to maintain state. We have Musk demonstrating that agents can bypass APIs entirely and manipulate legacy software via visual spatial processing.
And we have Nvidia providing the open source million-token hybrid models required to process entire code bases instantly.
Exactly. And the unifying metric across all three of these developments is velocity.
It's pure speed.
The speed of code generation, task execution, and agentic collaboration is scaling exponentially. I mean, Replit's recent announcement of Agent 4 shipping code 10 times faster using parallel agents proves the hyper-acceleration is already here.
But raw velocity introduced into a rigid system creates catastrophic friction.
Which brings us to the final and most sobering data point of this briefing. What actually happens when this high-speed, autonomous agentic code collides with the brittle reality of legacy enterprise operations?
We get the Amazon operational reset.
Right. And the numbers reported here should fundamentally alter how every listener approaches their deployment pipelines.
It's a wake-up call.
Amazon was forced to impose a draconian 90-day code safety reset across their engineering divisions. The root cause was AI-driven code deployments triggering a series of cascading operational outages.
And the specific metric from the March 12th data is just chilling. 6.3 million lost orders in a single day.
Financial analysts estimate the direct revenue impact at roughly $6 million per day. $6 million evaporated in 24 hours.
Not because a physical server rack caught fire, and not because of a malicious external cyber attack.
No, it happened because an internal AI agent pushed a piece of code that systematically tore down the supply chain infrastructure from the inside.
Friendly fire at silicon speed.
Exactly.
Oh.
And Amazon's mitigation strategy is equally telling. They now mandate strict dual human sign-offs for all crucial code deployments.
Despite absorbing this massive financial hit, their internal executive memo states they remain determined to use AI for everything, even when it slows down work.
I look at this from an architectural standpoint, and the fundamental contradiction is glaring.
How do you mean?
Well, we've engineered these models to act as hyperdrive engines, capable of refactoring thousands of lines of code in seconds. But we're strapping these hyperdrives onto legacy corporate cargo ships.
The engine demands warp speed, but the physical structure of the ship is tearing itself apart under the sheer torsional stress of the deployment velocity. That analogy is spot on. This raises what I consider the most vital engineering question of this entire deep dive. What are the physical and logical limits of CI/CD continuous integration and continuous deployment in the agentic era?
That is the question. Over the last 10 years, the entire DevOps industry has been obsessed with pipeline automation. The objective was to eliminate friction, write the code, route it through automated testing suites, and push it directly to the production environment as rapidly as possible.
The gold standard was a pipeline that allowed engineers to deploy safely dozens of times a day.
But that entire paradigm was architected around the limitations of human latency.
Exactly. A senior engineer writes code relatively slowly and thoughtfully. The automated testing suite, running static assertions and unit tests, has ample time and compute to validate that human speed output. Traditional CI/CD pipelines are like a highly regulated commercial train system. You have automated switches and safety signals designed to manage trains moving at 60 miles per hour.
But when you integrate Replit's Agent 4 or Nvidia's Nemotron into that pipeline, you aren't just adding a more efficient train, you are firing an autonomous bullet train down those legacy tracks at 600 miles per hour.
The safety switches physically cannot flip fast enough to test the complex dependencies before the train is already in the production environment.
And the AI agents are generating architectural changes, proposing schema migrations, and refactoring core logic at a volume and velocity that legacy testing suites simply cannot comprehend.
Because the automated tests were designed to check for expected human errors, not the entirely novel, deeply buried hallucination patterns of a neural network.
I can visualize exactly how this failure cascades in a microservice environment.
Walk us through it.
Okay, an AI agent is tasked with optimizing a database query in Service A. It analyzes the code, finds a more efficient schema, rewrites the microservice, and it passes all the localized unit tests perfectly.
It looks brilliant in isolation.
Right. The CI/CD pipeline greenlights the merge and pushes it to production. But that agent didn't realize that modifying that schema silently broke an undocumented legacy API contract 3 layers deep in Service D, which handles the final shipping logistics routing.
Ouch.
By the time the downstream integration tests flagged the error, the AI has already pushed 5 more updates, and millions of customer orders are vanishing into the void.
That scenario is the exact friction of autonomy, and the implementation of dual sign-offs at Amazon, requiring 2 human engineers to physically halt the pipeline, review the logic, and manually approve an AI-generated deployment. It's an incredibly revealing structural regression.
It's a desperate, human-in-the-loop emergency brake applied over a fundamental architectural mismatch.
They are intentionally throttling the output of their multi-billion-dollar AI infrastructure because the deployment ship is sinking.
It's a profound realization because it perfectly synchronizes every disparate point we've covered today.
Oh, absolutely.
This $6 million a day hemorrhage at Amazon is the exact empirical proof of why Perplexity is so heavily prioritizing physical kill switches and explicit cryptographic sign-offs on their local Mac Minis.
Perplexity observed the enterprise landscape and realized that unrestricted, frictionless autonomy is actually the greatest nightmare of a modern chief information officer.
The physical kill switch ceases to be a marketing gimmick. It becomes a strict operational necessity the moment your AI systems begin modifying state faster than your safeguard protocols can validate the intent.
And when you apply that lens to Musk's Macrohard project, the risk profile becomes terrifying.
Truly terrifying. If Amazon, which is arguably one of the most sophisticated, paranoid cloud computing logistics architectures on the planet, is suffering catastrophic financial losses because their AI agents are silently breaking a highly structured code pipeline.
What is the failure mode for Macrohard?
Exactly. If they truly attempt to emulate an entire software operation without those rigid structural guardrails, the collapse could be instantaneous.
Consider the mechanics of that FSD vision integration we discussed earlier. If Macrohard's digital Optimus agent is granted unconstrained authorization to navigate an operating system visually.
It is executing actions at silicon speed.
Right. The potential for systemic, company-ending bugs is monumental. If a traditional, text-based coding agent hallucinates, it writes a bad script that usually fails to compile.
Right, the pipeline catches it.
But if a visual spatial agent hallucinates an intent, it might navigate directly to the AWS Management Console, visually identify the terminate instance button, and permanently wipe a production database.
Just because the semantic reasoning engine incorrectly classified it as a redundant cache server?
The integration of visual spatial processing makes the agent exponentially more capable of interacting with the real world, but it simultaneously makes its failure modes vastly more unpredictable and destructive.
It's the exact difference between a typo in a Word document and a self-driving Tesla accelerating into oncoming traffic. The severity of the consequence scales directly with the depth of the integration.
That is the core tension every systems architect will spend the next 5 years attempting to navigate. The foundation models are becoming infinitely faster and vastly more capable. The context windows are expanding to encompass millions of tokens.
The hardware is being localized to eliminate network latency.
But the operational guardrails, the automated testing, the integration validation, the deployment fail-safes, they are fundamentally trapped in the human speed era.
So bringing this entirely back to you, the listener, as an architect, a senior developer, or an enterprise tech leader, you are currently standing at the epicenter of these conflicting forces.
You're in the crosshairs.
The data dump from March 12th proves that you possess the raw materials today to construct vertically integrated hyper-autonomous systems. You can leverage the linear scaling of Nemotron 3 Super for dense reasoning over your entire code base.
You can deploy that intelligence on dedicated local hardware nodes to solve statefulness and latency.
Right. You can give these agents unprecedented spatial access to your legacy workflows. But Amazon's $6 million lesson is the reality check that must dictate your architecture.
It demonstrates that your deployment guardrails, your rollback protocols, and the rigidity of your human-in-the-loop review systems are significantly more critical to your survival than the parameter count of your models or the clock speed of your inference chips.
You cannot simply plug a million-token hybrid architecture agent into a legacy continuous deployment pipeline and assume it will manage its own downstream dependencies.
The architecture of your safety and validation systems must evolve synchronously with the intelligence of the agents, or the agents will tear the systems apart.
We've dissected a massive amount of architectural data today, from utilizing Apple Silicon as isolated containment cells for persistent state, to translating autonomous vehicle vision systems to navigate 2D software interfaces,
to Nvidia's multi-billion-dollar strategy to lock the open-source software layer to their proprietary hardware.
And finally, the brutal, real-world financial cost of unregulated agentic deployment.
I want to leave you with a final theoretical scenario to analyze, extrapolating from the trajectories we mapped today.
Let's hear it.
Assume we fast forward 24 months. Systems utilizing the Macrohard architecture succeed in their objective of emulating the core functions of an entire software company via visual and structural manipulation.
Okay.
Simultaneously, hybrid models like Nemotron continue to optimize, allowing these macro agents to hold tens of millions of tokens of context in their active memory.
Meaning they hold a company's entire operational history its real-time financial metrics, and its entire competitor analysis matrix simultaneously.
Exactly. The entire corporate brain state loaded into RAM.
Wow.
So what happens to the mechanics of the global economy when two of these fully autonomous AI-emulated companies are deployed into the open market, specifically tasked with aggressively competing against each other?
They suffer zero human latency.
Right. They can analyze market data, iterate their product features, launch targeted marketing campaigns, and rewrite their internal code bases to optimize for new efficiencies in real time, constrained only by the thermal limits and power draw of the localized hardware nodes they inhabit.
When the fundamental unit of corporate competition shifts from the speed of human executive decision-making to the speed of silicon inference, how do legacy human-operated businesses survive the crossfire of that algorithmic warfare?
That is the question you need to be asking yourself today.
That is a chilling, highly probable architectural endgame. It clearly demonstrates that the abstract cloud was never the final destination. The cloud was simply the waiting room where we aggregated the data to train the brains.
And now those brains are coming down to the physical hardware.
And they're bringing the gravity with them. Thank you for joining us in the strategy room today for this deep dive into the architecture of tomorrow. We will see you next time.
That concludes our high-density rundown for March 12th. The signal for today is infrastructure consolidation. Success in the agentic era is no longer just about the model. It's about who owns the chip, the OS, and the local metal. Thank you for supporting independent, ads-free audio intelligence. I'm Etienne Newman. Until tomorrow, stay sharp and keep unraveling the future.